Yep, you can go.
I can go. Excellent. Dimensions. So, if you start off, dimensions, we live in a three-dimensional universe, but if you start off by considering a universe without dimensions, or a dot, but not a dot as we've got on the board, it's impossible to represent in our universe, but you need to imagine something that has no length, no width, no depth. That is a dot, an absolute point that can be no smaller. However, unless you are going to put, if you want to make two dots, and unless you put the second dot right on top of the first one again, you have to put it somewhere else. And if you put it somewhere else, you need to extend something to contain the two of them, and that's how you get a dimension. So, if you extend from one dot to another dot, you get a line. And this is now the first dimension. And I'll gloss over the first three because you should already be familiar with them. You have width, which is the second, and I apologise for my voice, and you have depth, which is the third one. So we are free to move within these various dimensions. Would anyone like to be filmed? Anyone put a check? Anyone want to be filmed? No.
What do you want? Just
I need someone to go and stand in front of the board and act as a puppet.
I'll do it.
Yellow.
Excellent. Okay, so quick demonstration to prove that we can move within three dimensions. Would you please take a step, stand in the middle? Excellent. Take a step forward. Take a step backward. That was supposed to be length, but we got width in there as well. Take a step to your left or right, whichever one is not going to hit us too much. And then back. That is the second dimension. Jump in the air. There we go, third dimension. We can move equally, and you're fine now. Thank you. We can move equally and easily throughout the three dimensions.
Right isn't backwards.
And that's why we have a three-dimensional universe. However, once you get past three, it gets a bit more complicated, and it is possibly worth giving up, but that would, of course, cut my short way too short. So we're going to carry on regardless. Because we live in a three-dimensional universe, we can only think of what we view as spatial dimensions, and we think in three dimensions. And our three dimensions are the ones that make up space. But if you take space and you put another point outside of it, you have to extend into a fourth dimension. And this fourth dimension creates space-time. It's not time itself, that's different. So the best way of expressing this is duration. Duration is the fourth dimension. It extends from the beginning of the universe in one end to the end, however it will come about, at the other. And we are constrained within this one. We can only move one way along it. And the direction we move in is called time. Not the dimension itself, but moving forward through that dimension is called time. And then equally, if you do backwards, you get anti-time. And then James has a lecture on time for us later on. But we're basically constrained within this. We can only move one way, and we don't choose how fast we move or anything to do with how we move.
Sure, if you spend really close near a black hole, it will go more slowly.
Theoretically, yes, but we're trying to be basic here, Patrick. This is complicated physics. So if we take the fifth dimension then, and I put my piece of paper which tells me what the fifth dimension is somewhere else, so I'm just going to have to wing it at this point. If you take, to visualise this, if you imagine you've got that cube, which is four-dimensional because it's moving forward through time, and compress it down until it becomes a dot, you can then extend another point outside that dot, and you end up with two dots, right back where we started. This is a visualisation. You have to just imagine that each dot is a four-dimensional universe. Now to connect those two dots, we need a line. And our line is the fifth dimension. And the fifth dimension is linear parallel worlds. Linear parallel worlds are basically, if you go back to, this is another way of showing it. We're going to shrink our little cube again, down to a point. If you have a linear parallel world, they have the same point in common. Take that one. If that's the Big Bang, then a linear parallel world will be there, 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 there. Any of these other points. And so, by connecting them up, we end up with many, 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 many individual linear parallel worlds. But then, that means we have alternate dimensions. Except it doesn't, because there are no alternate dimensions. There is 1, 2, 3, 4, 5, that we've got up to, and many more. But you can't swap one fifth dimension for another one. So sci-fi is wrong. It's not an alternate dimension, it's an alternate universe. So, 6. If you take the little model that we had before, the fifth dimension, and then we put a point outside that. This is very, very quick, so I can't explain why it's a line, but it's a line. you get the sixth dimension. So if on the fifth dimension all the universes are ultimately universes start at the same point, then within the sixth dimension we have planar parallels. We have ones with different starting points. Big Bang could be one. Maybe we have a different one where the Big Bang, there's slightly more antimatter than there is matter, or something like that, and it changes the universe as it is. And George, I've just realised I need sound.
Just have a go.
Have a go. Which bit do I connect? And within our sixth dimension, you have contained within many different points, which start at various fifth dimensional little things themselves. Right. So, seventh dimension. Seventh dimension is controlled by the laws of physics, and so basically, this is an example of a law of physics. Electricity always follows the path of least resistance. It's not particularly clear on the board, but there's a shiny light bit in the middle. That's a metal ball. So if you use a Tesla coil, which is a high voltage generating machine, electricity will jump from the Tesla coil to the little metal ball, or it will jump to the floor, because they're the quickest and easiest ways it can go. And so, there we go. So watch where it jumps.
That's so cool. D C G. That's so awesome. And this all better me once again, and I think it's the same. I think that's good. Don't really see them.
So that's an example of a law of physics. In all of the universes contained within, whichever one we're on now, 7, it's all the possible universes that could exist with the same laws of physics, the same set. So in all of them, electricity will always follow the path of least resistance. However, then you have to put a point outside that, which is a phrase I'm using far too much. Oh, there we go. So if we condense our current universe down again, so that we have a point that we can stick something outside of, we have, again, the many points theme. So each one of these would be a different universe with a different set of physical constants. And they could be set physical constants that are just different to ours, or they could be oscillating, which, so for example, if you take the speed of light, which in our universe is roughly 3 times 10 to the 8 meters per second, it could be oscillating, it could change in a different universe. Right. 9. How long have I got left, just out of interest?
10. Just over.
Really?
It's fine, carry on.
Okay, brilliant. So 9 is where we get slightly more confused, because the only way you can represent 9 is with a blank screen. And this is where my notes come. Ah, yes. So, this is where you get ideas or information that's constrained within structures in the information that makes up matter that you can no longer really understand. They can't be represented physically. And so the ninth dimension is impossible universes. So taking it beyond laws of physics and things into things where you don't have laws of physics, or something equally mind-melting.
Physics breaks the rules.
Physics breaks, yes, exactly. And so from 9 you go up to 10. If 9 was impossible universes, then 10 has to contain them and then be one step further. It has to have a point outside of them. So 10 is basically constricting all of them down again to the point.
Takes a long time.
At which you get everything. 10 is everything. Everything. The simplest way to describe it is everything. Which then makes this one slightly paradoxical.
This is nothing.
Kind of. It is. The 11th dimension is basically a mathematical idea, because string theory won't work until you get to the 11th dimension. And the 11th dimension is everything, but with the same thing happening again. You make everything go very, very small. until it vanishes.
I guess doesn't it?
Unfortunately, there's a very, very small dot there that I can't see on my screen, so you'll have to excuse that, it's not there anymore. If you imagine, and I was going to attempt this, then I realised that I'd have to climb a ladder and nail something to the side of the hall. But basically, if you imagine a piece of paper, such as this one, with its lines. At present, can you all see the lines? If I was to take this and go and nail it to the wall of the hall opposite, would you still be able to see the lines?
Possibly, probably.
Then the best way of thinking about the 11th dimension is to imagine looking at everything, but from so far away that everything looks the same. Yeah?
That vary for difference between or
Well, no. This is a metaphorical. You can't look at everything. That would be horrible.
Why? It'll look the same.
Steve, have you not seen any other journeys? When the lady at the end
She's
is
very
gifted by
happy.
the aliens,
She's very
her
happy.
eyes burn up.
Eyes.
Would you not want to see everything?
She's happy when she dies.
Steve, can you
She's
see
happy
everything?
when she dies. So there you go.
Are you
Here's
happy
the
when
quiz
you
on the
die?
11 dimensions as defined by various people
No,
much,
website
much
called-
cleverer than I am. And if you want more information, you can visit the website that is very contradictory by saying 10 dimensions by Mr. Rob Brandon, which sounds like some sort of obscure dinosaur. Thank you.